All right, this is AP, AB, and BC Calculus. We're doing Unit 6, Section 10, which is integration of functions using long division and completing the square. All right, so we're going to integrate x squared plus x minus 12 all over an x minus 3. So the hint I give you is that factoring helps. So I'm going to do a little bit of work that is not going to involve the integral. I'm going to see what happens if I factor x squared plus x minus 12, right? So it's over an x minus 3. I'm going to take a shot in the dark that if I factor the top, I get an x minus 3. And sure enough, it's x plus 4x minus 3. And you can double check that that's true, but they multiply to negative 12. They would add to a positive x. So what you'll notice is if I cancel these, I get that this thing is actually just an x plus 4. So what I'm integrating, right, so I did a little bit of work and I separate it to make it clear. I'm actually integrating x plus 4 with respect to x, which means I'm going to get an x squared over 2 plus a 4x plus c. Now the other way to get that is to use long division if you didn't spot that, but I'm going to suggest that if factoring is a choice, if something does factor and something cancels, that's always easier. Go ahead and try a P1, right? Again, I don't care if you don't have to do the work separately. You could just factor right above this if you want, right? This is going to factor into an x plus 2 times an x plus 5, which means I can cancel the x plus 2's and get that this is the integral of x plus 5 with respect to x. So this is an x squared over 2 plus a 5x plus c. And remember, it's always okay to write this as a 1/2 x squared instead of an x squared over 2. I don't care. That's just a style preference. All right, so now it's not going to pan out the way that it has in the last several problems. So now I'm going to have to do a little bit of work, and that work is going to involve division because x squared minus 7x minus 11 does not factor. And even if it did factor, it doesn't factor in a way that cancels the x minus 8. So I'm going to either do x minus 8 and divide it into x squared minus 7x minus 11. That's fine. Or because x minus 8 is a linear factor, I could do synthetic division, which I'm going to argue is a lot easier. So I could put an 8 here, 1, negative 7, negative 11. It's up to you. I really don't care. I'm going to walk you through both. If I did synthetic, I'd drop the 1 down, multiply the 8, and add straight down. Multiply the 8 and add straight down. This is my number, and this is my x. If I did it this way, I get that this whole thing is equal to an x plus 1 plus this negative 3 over the original factor. Great. If I do it this way, the same thing's going to happen. I'd multiply by an x to get an x squared minus an 8x, and then when I subtract, the negative goes to both terms, so I get negative 7x plus an 8x, which is an x, minus this 11. In order to make this x look like an x, I'm just going to multiply by 1, so I get an x minus 8, subtract straight down, and sure enough, I end up getting that this is a negative 3. So I get the same answer either way. This is what that turns into. Now, that's not my final answer, right? That's just the work. I still have to do all the calculus. So this is not calc, right? This is then the integral of x plus 1 plus this negative 3 over the x minus 8. So I'm going to integrate each piece individually. So the x becomes an x squared over 2. The plus 1 becomes a plus x. And then this is actually technically u sub. So this is sort of that perfect example where I told you that sometimes you're using u sub in subtle ways even when it's really not obvious. Technically, my u is x minus 8 and my du is just a dx. So this is a negative 3 over u du. This integrates to a negative 3 natural log of the absolute value of x minus 8. That's an absolute value, plus c. So I ran a little bit low on space, so we'll copy that down here again just to make it clear. When I integrate this, I get x squared over 2 plus x minus 3 natural log of x minus 8 inside an absolute value plus c. So technically, this piece is u sub, right? It really is. It is u sub. It's just a really simple u sub, right? So what's happening is I'm getting, I am actually doing u sub, I just most of the time we don't write it down. So I want to point out that when I said the u sub video was important, I'm not kidding. Even these problems that are complicated in tons of ways might end with some simple u sub that you may not even use the u for. Like even though you know logically that it's variable substitution, you might not use the u. All right, go ahead and give this one a try. Again, hint, division helps. I want to point out how much faster synthetic division was, but again, it's totally up to you how you divide, right? So I'm going to go ahead and do synthetic division where x minus 6 is 0, so x is 6. when I do my synthetic division, I'm going to quickly get an answer that would take longer with long division, right? So drop the 1 down, multiply, add straight down, multiply, add straight down, and this is my number and my x. So I get that this is actually an x plus 5 plus a 1 over the original divisor. So that's not calc, but if you can't do that, you're going to kind of be dead in the water and not be able to figure out what to do next. So I'm integrating x plus 5 plus a 1 over x minus 6 with respect to x. Well, this integrates to an x squared over 2. This integrates to a 5x. And then this is technically u sub, right? This piece is actually, like, even though we're going to kind of cheat and not probably write the u sub, this is very subtle u sub, right? Because there is a function in your function. Your u is x minus 6. Your du is conveniently dx. So you're integrating 1 over u du. This is going to be the natural log of the absolute value of x minus 6 plus c, right? Again, if you're able to do that level of u sub in your head, nobody thinks that's cheating, but this is what I mean when I say you really need to make sure you know how to do u sub. So for example 3, we're asked to integrate 5x squared over the quantity 2x plus 3. So the hint is that division helps. Because the divisor, although linear is a 2x plus 3, it's not going to work well with synthetic division. The fractions become really frustrating in general, so I'm going to suggest that you use long division here. So this is a 2x plus 3, and then a 5x squared, and then nothing after that for right now. So in order to make a 2x look like a 5x squared, I need to multiply by 5 halves x. And if I distribute that, I'm going to get a 5x squared plus a 15 halves x, and I'm going to subtract straight down. So I'm going to get negative 15 halves x, right? In order to make a 2x look like a negative 15 halves x, I'm going to need to multiply by a negative 15 fourths. So I'm going to get negative 15 halves x minus 45 over 4, and then I'm going to subtract straight down, and what's going to happen is I'm going to end up with a remainder of a positive 45 over 4. Now I get that that's not super fun, but all of that makes it so that I can rewrite this integral as the integral of 5 halves x minus 15 fourths plus this 45 over 4 divided by the 2x plus 3 with respect to x. So the first two are fairly straightforward. The last one will require u sub. So this one's going to require u sub. This piece integrates to a 5x squared over 4 because I'm going to raise the power to 2 and divide by 2. 5 halves divided by 2 is 5 fourths. Right, this is a negative 15 fourths x. Those two are pretty straightforward. To do the third piece, you may or may not need to write this u sub down. This might be u sub that you feel comfortable doing in your head, but we'll see. So your u would be 2x plus 3. Your du would be 2 dx. So you're going to have a 1/2 here. You're going to get a du over 2 is your dx. So this is going to be the integral of a 45 over 8 over u times a du. So I'm going to get that this is 45 over 8 natural log of the absolute value of 2x plus 3 plus c. That's what this piece turns out to be, right? That's my u sub for that piece. If you can do that u sub in your head, that's great. If you can't, that's also great. It doesn't matter, but you have to be able to do that u sub. So this is what I mean again when I say that u sub is a really key final step in some pretty long problems. The u sub is meant to be the easy step because this is a fairly long problem. So I tried to fit it all in one line and kind of failed, so don't forget the plus c. There you go. All right, moving on. All right, same idea. Again, because your divisor, although linear, has a coefficient that's not 1, and because that 3 doesn't go nicely into the -4, I'm going to suggest that you do your work as long division instead of synthetic. Synthetic creates some interesting problems if you do it that way. So anyway, 3x minus 1 going into a -4x squared. So to make a 3x look like a -4x, I'm going to have to multiply by a -4/3 x, right? And I meant to say squared when I said -4x, so -4x squared. So I'm going to get -4x squared plus a 4/3 x, and I'm going to subtract straight down because that's how we do with long division. These go away, and I get a -4/3 x. Well, to make a 3x look like a negative 4/3 x, I'm going to have to multiply by a negative 4/9, right? So I'm going to get negative 4/3 x plus a 4/9, and then I'm going to subtract straight down, and that'll end up being a remainder of negative 4/9. So all of that work is to be able to rewrite this as the integral of negative 4/3 x minus 4/9 plus a negative 4/9 over this 3x minus 1. So again, the first two are going to be fairly straightforward, right? This is going to become a negative 4x squared over 6, which we can simplify into a negative 2/3 if you want, right? Minus a 4/9 x. And then for this one, I'm going to have to do a little bit of u sub, like some fairly straightforward u sub, right? So when I do my u sub here, right, I'm going to have to recognize that if my u were a 3x minus 1, my du is going to have a 3 in front of the dx. So there's going to be an additional 1/3 that has to go into this. So this is going to be a negative 4/27 over u du, right, because of that extra 1/3 that has to be in there. So I'm going to get that this is a minus 4/27 natural log of the absolute value of 3x minus 1 plus c. So again, I would love to manage to squeeze this answer into one line, but it didn't work in the last slide either. If you want to clean this up, it's a negative 2/3 x to the second minus 4/9 x minus 4/27 natural log of 3x minus 1 all plus c. Hey, look, there I made it into one line. Yay! All right, moving on. All right, so you're going to integrate, and the hint is completing the square helps. So right now, there's no way that u sub is going to help you because you don't have anything on top at all. So it's definitely not classic u sub. So the hint was complete the square, so we might as well just go ahead and complete the square, right? So x squared plus 10x plus 26. When I complete the square, I ignore the constant, so I'm going to awkwardly move the 26 away, right? I factor out the a, but here the a is just 1, so it doesn't really drastically affect my life anyway. I do that triangle step, right? We divide by 2 to get a plus 5, and then we're going to square it, so we're going to add 25. So I just added 25 out here, which means that to maintain that balance, I have to subtract 25. So I'm going to get that this is an x plus 5 quantity squared plus a 1. Once I know that, right, once I do that complete the square step, this is the integral of a 1 over, and I can write the 1 in the front, it doesn't matter because addition is commutative. And I suddenly find myself in a situation where I have an arctan. My a squared is 1 squared, so a is 1. My u, sorry, there was a dx there. My u is x plus 5, so my du is dx. And what I have here is the integral of 1 over a squared plus u squared du. That's an arctan. That's 1 over a, the arctan of u over a plus c. Well, once I know that, I say, cool, that's 1 over a arctan of u over a plus c. So I'm just going to write this as the arctan of x plus 5 plus c. All right. So go ahead and try this one, right? Again, the hint is that completing the square would help, right? So I know that it's x squared plus 2x awkwardly far away 10. Factor out the a, although the a in most of these is a 1, so that's not awful. And do my triangle step. So I divide by 2, which will give me a positive 1, and then square it, which will be a plus 1 out here. Since I just added a 1, I subtract 1 out here. I'm going to get that this is x plus 1 quantity squared plus 9, or if you want to write it in the order that you've been seeing it for arctan, because this is another arctan, you can write this as a 3 squared plus that x plus 1 squared, and there's your arctan. So this is the integral of 1 over 3 squared and then an x plus 1 quantity squared dx. So my a is 3, my u is x plus 1, which makes my du a dx, and I suddenly have an arctan. A squared plus u squared with a du. So this integrates to 1 over a arctan of u over a plus c. Sorry, I'll separate my work a little bit, right? So I'm going to get that this is a 1 over 3 arctan of x plus 1 all over 3 plus c. All right. Okay, so again, the hint is completing the square is going to help. So I'm going to do my work, and my guess is that this is going to turn out to be an arc sine. So I need to complete the square of this thing. I don't need it to be in the root to do that. I just need to clean up this thing. So first thing I'm going to do is ignore the constant. Then I get to factor out a, and here a does matter because it's a -1. Notice I'm only taking out that a. I'm not taking out the x as well. I do my triangle step. I divide by 2 to get a -2, and I square it to add 4. But I didn't really add 4. I subtracted 4, right, because it's -1 times 4. So out here I'm going to do the opposite of subtracting 4, which is add 4. So I'm going to get this as a -1, x minus 2 quantity squared plus a 9. If I rewrite that, that's a 9 minus this x minus 2 quantity squared. Or better yet, actually, we'll clean that up a little. It's not a 9, it's a 3 squared because it's my a squared. So if I rewrite this, this is the integral of 1 over the square root of 3 squared minus this x minus 2 quantity squared dx. Well, my a is 3 and my u is x minus 2, so my du is dx. Suddenly, I have an arc sine. This is a 1 over square root of a squared minus u squared du. So this is arc sine of u over a plus c, which means my answer is that this is an arc sine of u, which is x minus 2, over a, which is a 3, plus c. All right, go ahead and try completing the square for this one. And again, I should have separated my work out to make it clear that that's not the calc. My bad. All right, so when I do my work, I'm going to go ahead and complete the square on -x squared minus 8x plus 9. Right, first thing you're going to do is ignore the constant. Right, you're going to factor out a -1 and get an x squared minus, plus 8x, my bad. And again, the plus 9 is just chilling there. When I do my triangle step, I'm dividing by 2 to get a plus 4 and then squaring it. So I write plus 16, but notice I didn't actually add 16. I subtracted 16, which means I have to add 16 out here for balance. So I get a -1 times this x plus 4, quantity squared, plus a 25, which I'm going to rewrite as a 5 squared minus this x plus 4 quantity squared, and suddenly I have an arc sine. So this is the square root of 5 squared minus this x plus 4 quantity squared dx. So my a is 5 and my u is x plus 4, which makes my du a dx. So this is the integral of the square root of a squared minus u squared over du, which means I have the arc sine of u over a plus c. So my answer is that this is, let me separate the algebra work again. This is the arc sine of u, which was x plus 4, over a, which was 5, plus c. All right, couple more. All right, so let's do an E6. All right, so now we're going to do an integral with bounds. My argument here is that, again, just because there are bounds doesn't mean that we shouldn't do the work the same way we've been doing the work and then just go back and deal with the bounds later. So I'm going to recognize that this integral, so I noticed the x minus 7 on the bottom, and I'm hopeful that the top will factor for me, but I don't think it will. I was hoping that the top would have an x minus 7, but it doesn't. Yeah, doesn't factor, so that's no fun. So I was hoping that the top would factor with an x minus 7, but it doesn't because it's a -3 here, and if this were a 7, that would have to be a -4, so that's a bummer. So I'm going to go ahead and do synthetic division, right, because x minus 7 is a nice, happy linear factor that also doesn't have a coefficient that's not 1 in front of the x. So I'm going to go ahead and do my division, and I was really hoping it would turn out to be one that factors, but it didn't. So I drop the 1 down, I multiply and add straight down, I multiply and add straight down. So I get that this is an x plus 4 plus the 7 over the x minus 7. So when I integrate this, right, what's going to end up happening, and again, this is sort of simple u sub, right, but if you were going to integrate the x plus 4 and the 7 over the x minus 7 dx, right, what's going to happen is I'm going to get an x squared over 2 plus a 4x. That's pretty straightforward. And then this is a simple u sub problem, but again, if you don't need to show it, if you can say, wait a second, I get it, the u is x minus 7, because du is just dx, that's sort of the simplest version of this. I'm going to get that this is a 7 over u du. So I'm going to get that this is a 7 natural log of the absolute value of x minus 7. So that's what this thing's going to integrate to. So again, I separated it. I clearly said, hey, this is just work. So then I can kind of cheat and say, cool, this is x squared over 2 plus 4x. plus 7 natural log of the absolute value of x minus 7. And I'm going to evaluate that whole thing from 1 to 3. And then I plug in, but notice I at no point said that the indefinite integral was equal to the definite integral. I did all my work separately and then just plug in at the top. So when I plug in, I'm going to get 9 halves plus 12 plus 7 natural log of 4, because it's the absolute value of that negative 4, right? So that's my top bound, minus, when I plug in the other one, I'm going to get 1 half plus 4 plus a 7 natural log of 6, right? And I can clean this up a little bit, but there's going to be a certain limit where I can't do much more. So I'm going to get a 9 halves plus 12 and a plus this 7 natural log of 4. When I distribute the negative, I get a minus 1 half and a minus 4, which I'm conveniently lining up with the thing that will line up with that, and a minus 7 natural log of 6, which doesn't actually in any way combine with the natural log of 4. So I seem to get 8 halves, which is convenient, so that's just a 4, plus an 8, right? Plus a 7 natural log of 4 minus a 7 natural log of 6. So the last thing I can do, and I'm just going to kind of drag this answer down here, I could make this a 12. You could either leave this as 7 natural log of 4 minus 7 natural log of 6, which is not wrong. Okay, sorry, my handwriting is terrible. Or I guess you could factor out the 7, and then because it's a natural log of 7, or a natural log of 4 minus natural log of 6, you could combine them into one log using division. So you might see this, if the AP wanted to trick you, as this, or better yet, this, if they wanted to try and trick you. So there's a chance you might see it like that, but this answer is totally fine. It's just a possibility that you might see it that way. And again, it's always a good idea to check your answers on these definite integrals on a calculator, because it doesn't hurt to see what's going to happen and see how you did. Now on this one, we're going to get ugly decimals no matter what, so we're going to have to check with ugly decimals. But even though you're not required to do this, it's always a good idea to check these as you go, because that's how you build the calculator skills, and it's also how you know if you did something wrong integrating yourself, right? And there's a chance I did, because there's been a lot of math to this, and honestly, I've been doing these videos for hours. So there's my y1. I'm going to quit out of that. I'm going to second enter because I've already been using my calculator in this way to check things today anyway. So I already have my y1 in. I want to integrate from 1 to 3, right? I'm going to get an answer, right? And it's going to be ugly, and I'm not going to be able to math frac it because of these natural logs, right? So if you look at my answers, I can't math frac it. I'm going to type in the easiest version of this that I got, which is the 12 plus 7 natural log of 2/3, and we're just going to roll the dice and hope that it's right, and it might not be, but we'll find out. Hey, that's exciting. So yay, we're right. Okay, so one last one to try. You're going to try this one. Yet again, it does not factor, so you're going to have to gut it out and do the division. So I'm going to go ahead and do the work. The synthetic division would use -6, right, because I'd set the x plus 6 equal to 0. So you can see how many of these skills are involved in each one of these problems. So all of the time that I've spent in classes bothering you saying, hey, I need you to build these skills up, I promised that there was a reason, and the reason was that a lot of the calc skills we see are going to use every single skill that you've seen, or a lot of the skills that you've seen over the last several years. So this is what this breaks down to using algebra, which means that if I were to integrate this, right, x minus 1 plus the 9 over x plus 6 with respect to x, right, what I would get is x squared over 2 minus an x. And then again, this is that simple u sub. When I say simple u sub, essentially what I'm saying is when du is conveniently dx, it's much easier u sub. So I'm going to get 9 natural log of x plus 6. And again, because du is dx, it's a pretty straightforward u sub. So this is the thing I'm going to have to plug into. So let's go ahead and separate the work a little bit, right? So I'm going to put that bracket to say that that's why I didn't put the plus c. So now I'm going to get that this is x squared over 2 minus x, my bad, I put a plus and didn't mean to, minus x plus a 9 natural log of the absolute value of x plus 6, and we're going to evaluate from 2 to 4, right? So when I do that, when I plug in the top bound, I'm going to get 16 halves minus 4 plus 9 natural log of 10, that's my top bound, right, minus, when I plug in 2, I'm going to get 4 halves minus 2 plus 9 natural log of 8, right? Cool. When I clean this up a little bit, this is an 8 minus 4 plus this 9 natural log of 10. There's nothing I can do with that right now. Minus, this is a 2 minus 2, so that's just gone. So minus 9 natural log of 8. Great. So I end up getting 4. And the way you're probably going to see this is with the 9 factored out, and then because these are being subtracted, you can make it 10 eighths. So you might see this answer, if it were multiple choice, as 4 plus 9 natural log of 5/4. That's probably what you'd see. So we'll just say that's our answer. Now let's go ahead and check, right? It doesn't hurt to check. So we go to our y equals, right? And I'm just going to change some values, right? Because thankfully I've already typed that other one in. So we have a plus 5x. This is a plus 3, and then I'll delete the extra 1. On the bottom, it should be an x plus 6. Right. So we'll quit out of this. We'll hit second enter, right, to get up to that function integrate. This time we're integrating from 2 to 4, right? And we're going to hit enter. And then, so we have this answer, and then we're going to type our answer in and see if our answer works. And, it probably won't because it's been a long day and adding is hard. But, can't hurt to check. So we type this in, and it works, and it's really exciting. So again, using your calculator to check is a really good skill in multiple directions. Number one, it confirms that you're integrating properly by hand. Number two, it confirms that you know how to use your calculator. I guess in theory you could do both wrong and somehow magically get that they're the same answer, which wouldn't be great, but it's statistically unlikely. So that's our video on long division and completing the square.